Hello and welcome to session 3 for anybody who's tuning in on YouTube. So the first slide that I tend to show every week is this one. I've already said this kind of informally, but now we have formally begun. I'll repeat myself and say we'd love to hear from you. We'd love to hear about what we're doing right, and even more importantly, what we're not doing right, what we could improve. Because if we just have to sort of guess, we can make mistakes. Sometimes we do things that seem like a good idea and it turn out not to be. We're only human after all. There are lots of ways you can get in contact with us. Email us is a very easy way, admin@cpplondonuni.com. Another way that's great for sort of slightly more informal contact is to use Slack. So if you haven't heard of it, Slack is like a chat application that's really commonly used in the programming world. And in particular, Slack has a bunch of different organizations, a bunch of different channels discussing all sorts of topics. In particular, there's one Slack organization that's called CPPLang. This is not run by us, but it's sort of for C++ programmers around the world. And there are a couple of thousand people on this, I think. And we kind of piggyback off this. We've got our own little chat room in there. It's called #CPPLondonUni. And there are lots of people in there, lots of people who come to these regularly, who have come to these in the past. So if you've got any questions about anything, if you want to discuss anything, how do I do this, what's this, even practical arrangements, that kind of thing, then do join us on this channel. You can do so by going to this URL that's on the screen, slack.cpp.al. You can register on there, pop your email address in, it'll send you an email with all the details. You have to pick a password and stuff, but it's fairly straightforward. And you can download an app for your phone or your computer or whatever. Otherwise, you can use it via the web as well. So we do encourage everybody to join that. The other thing I should have mentioned at the start, but I didn't, is that this tonight is only half of what we do. So we actually run 2 sessions a week. There's the Tuesday night session, which is this, right now. And this is kind of more regular classroom type affair, right? It's me standing at the front, showing you slides, telling you new stuff, hopefully interesting. I do my best. We also run workshop sessions on Thursday evenings. So these are same location, except instead of a classroom, they're downstairs in the lobby. And these are really informal, sort of you drop in whenever you like, leave whenever you like. And these are designed as an opportunity for you to practice your programming, right? So we have an experienced developer, usually Ollie, one of my colleagues, is around and he's there and he can help you out, he can answer any questions, he can guide you along, help you out. If you're having any problems, if you want something explained, he's there, he's available, and his expertise. So I really recommend to get the most out of this. Not just to come along to one Tuesday every 2 weeks, right? That's good. But if you really want to get along and want to make the most of what we offer, then come along on the Thursdays as well. And also, make use of any resources on your own time as well. We kind of guide you along and give you a progression that we think is useful, and we'll gradually increase your knowledge at a pace that you can follow. But we also highly encourage you to go ahead and do your own reading, use your own resources, textbooks, websites, video tutorials, whatever works for you. Really encourage that. And again, if you come along on Thursdays, even if you've read ahead a bit, and have questions that aren't necessarily related to what we've done on Tuesdays, that's fine. That's really what we're there for, is to help you out with anything C++ related you might have questions about. Yes, you've got a question.
Can we expect Thursday anyone? Because last Thursday nobody turned up. So.
Yeah. Last Thursday, unfortunately, we had a bit of a communications failure. So Ollie was unwell, but I found out too late, and I was already busy. So usually, if Ollie can't make it, then I will come along on a Thursday. But unfortunately, this Thursday just gone, we had a bit of a communication.
Get notified or.
Yes, it was rather unfortunate. Apologies for that. Okay, so 2 weeks ago, as I mentioned, Ollie took the class because I wasn't well. There's been something going around, hopefully we haven't all been struck down by very nasty viruses that are doing the rounds at the moment. None of us have been on cruise ships, as far as I know, so hopefully we're all right. But yes, Ollie took the class, but he was following my slides, so you pretty much got what you would have had if I'd been doing it, except maybe talk better. But last time, you spent some time, first of all, looking at functions that we talked about previously. We started to look at using variables in our programs. So programs in C++, as in almost all programming languages, are made up of two things: data, variables, and functions that operate on those variables. So a function is just, when it comes down to it, a list of instructions. Functions take some input, perform some instructions on that input, and then optionally return some output. Right? And your programs are made up of functions and data which gets passed to those functions. And the data in our program, we call them variables because they can vary over the course of your program. So we saw how to declare variables in C++ and how to initialize them, give them initial values, and how to change their values. And if you are familiar with, well, pretty much any other programming language, really, the concepts are very similar in C++. The main difference in C++ compared to something like Python or JavaScript is that the notion of the type of a variable is very, very important in C++. So every piece of data we use in our program has a type associated with it. What do I mean by type? Well, a type, if you think about it, kind of at the lowest hardware level, all your computer knows about is ones and zeros. Right? Your computer memory is just billions of ones and zeros. Your computer hard drive is billions of ones and zeros. Right? And this idea of types is how we make sense of a bunch of ones and zeros. We say, okay, well, these 32 bits represent an integer, as opposed to these 32 bits that represent a floating point number. That's a number that has like a fractional part, 3.2 or whatever. Or this particular portion of data represents a string, like some text. So this notion of type is really, really important in C++. And it's actually probably something most of you are already familiar with, just from having used computers for, well, you're pretty young, so probably your entire lives, right? You're already familiar with the idea that files on your computer can have different types, right? You can have Word documents and MP3 files and JPEGs and PDFs and whatever, right? Well, on your hard drive, these are all just a bunch of ones and zeros. But your operating system associates a particular type with this data. And because it knows the type of this data, it knows what to do with those files. It knows, when you double click a PDF, it pops up the PDF reader, right? And if we try and fool it, in Windows you can just change the extension of something and it considers it a different type. Well, if you just take your Word document and change the .doc to .pdf, it's not going to work. And in the same way, there are ways of fooling, tricking the C++ type system to pretend a piece of data is a different type to what it really is. But most of the time, that's not going to work, because the function that you pass this data to is expecting data of a certain type, and if you have lied about what the type is, well, the function's it's not going to work as expected. In exactly the same way as if you tried to open a Word document as if it was a PDF. Those ones and zeros aren't in the correct places, and everything gets very confused. So anyway, got a little bit sidetracked talking about types, but it's only because we've got some new people here, and I just want to make sure everyone's on the same page. The point is, when we use variables, every variable, every piece of data we use in our program has a type that is worked out at the point we compile our program, and which doesn't change through the life of our program. Once we declared these variables, we also saw how we can pass these variables to our functions. So remember what I said, the function takes some input, performs some actions, just a list of instructions, and returns some output. So we saw how we can pass the variables as input to our functions. And finally, so this is Ollie, by the way, if you haven't met him.
Finally made it. Hi, everyone.
And then finally, Ollie, 2 weeks ago, went on to talk about if statements. So again, if you've done any sort of programming before, you're probably familiar with the notion of an if statement. So this is a keyword in the language, if, that checks some condition, and if that condition is true, it goes on to perform some action. And if the condition is not true, it does something else. So it's a way of making decisions in your programs. But that was last time. This week, to start with, we're actually going to take a little bit of an aside and take this opportunity to get everyone set up for using C++ and being able to write C++ programs on your own computer. So for the past couple of weeks, we've been using a website that lets you just input C++ programs just on the website and press a button, and it does everything kind of magically in the cloud. But that's kind of useful to get started, but it's not how people write C++ programs in real life. So we're going to get everyone set up with an editor and a C++ compiler. That's a program that takes C++ code and reads it and generates another program for you that you can actually run. So we'll spend the first part of this session doing that. I'll put the instructions up in a little bit. We'll have another brief look at if statements, because they were right at the end of the last session, and that was 2 weeks ago, and I just want to make sure everyone's on the same page. And then we're going to have a look at a type called a standard vector. And I will say a bit more about this when we get to it, but a standard vector is C++'s version of an array. It's like a collection of some other data type. Collection of lots of objects of some other type. So I'll explain what that is when we get to it, and then we're also going to look at something that's also really fundamental in programming. Again, that's something that all languages have some version of, and that's this idea of loops. Basically performing some action repeating some action a number of times. And again, yes, every programming language has some version of this, and we're going to go over the various options that C++ has for doing this. Time permitting, anyway, we got quite a big group tonight, so it might take a little bit longer getting everybody set up, but we'll see how far we get. So as I mentioned, so far the past couple of sessions we've just been using this online compiler, like a website that kind of you just write your code in a little box on the website and press the button and it does everything for you. In the real world, that's not how people do things. People do it, you write code on your own computer, right? You have an editor that you write your C++ code in, you save the file, you pass that text file that you've just written onto a compiler, which reads it and transforms it into a program that you can run on your machine. So today we're going to get everyone set up with a free compiler and a free trial of an IDE. So an IDE, if you haven't heard the term, integrated development environment, it's kind of like an editor on steroids, right? It's an editor, but it's also got added functions, so it can like run the compiler for you and handle things like running a debugger and stuff. Manage your project when you've got lots and lots of files. At any point in this, if you have any problems, if you need help getting set up, then please do ask us. That's what we're here for. Just put your hand up and me or Ollie will come along. So, is there anybody who's running anything other than Windows or Mac? Well, aren't you awkward? I'm assuming that if you're running Linux, you'll probably know what you're doing. But if you, I will come along and help you, especially. But for everybody else, step one of what we want to do is to install a compiler. So there are two different options, depending on whether you're using Windows or using a Mac. If you're using a Mac, it's really easy because Apple provide a free compiler and all you have to do is install it. And the way to do that is by opening a terminal window. So just go to I forget what they call it, the overview, just type in terminal. It'll pop up with this ugly 1970s text box. And you can just enter Xcode select, Xcode dash select, and then dash install. Press enter, it'll pop up a window. I think it asks you for your password and you've got to like accept the terms and conditions and whatever. But it's fairly straightforward. It'll take care of everything. For Windows, it's a tiny little bit more involved. You need to go to this website that's on the screen, so nuwen.net/mingw.html. And then it's got a couple of download options on there, but it doesn't really matter at this stage which one you pick. One's slightly smaller than the other. Your computer will save that. It's a zip file that automatically extracts. So extract that somewhere. C:/mingw is a good option. That's the default, I think. And you can run that, and when that's done, you're done for this step, and your compiler is ready to use. You've already done all this, so you don't have to worry.
How about Eclipse? Is it good or not okay?
How about Eclipse? So Eclipse, as far as I know, is intended mostly for using with Java. But it also has a plugin for it that you can use it to write C and C++ programs. I have to confess, I have never used Eclipse, so I know of it, but I don't know anything about it. So if you are familiar with Eclipse and if you're comfortable with it, then go ahead and use it. But I don't know enough about it to either recommend it or not, I'm afraid. Okay, so yeah. Go ahead and follow whichever one of these sets of instructions is appropriate. If you have any problems, raise your hands if you've done it and it's worked, then sit back and look really relaxed, and then I'll know everybody's done and we can move on to step 2. Okay?
Will there be a problem if we tried something like this before, but maybe it went wrong?
Probably not.
Okay.
The worst that'll happen is that CLion will put the wrong compiler that will fix that. That's pretty simple.
Is 17.1 also okay?
Oh, has he updated it? Is it now 17.1?
Yeah.
Oh, yes.
Yeah, that's fine.
Yes. Oh, I hadn't realised he'd updated the website. So the person who runs this is very, very well known in the C++ world. So that's why we use this and why we kind of trust this. And he updates this fairly frequently. So clearly he's updated it since I wrote these slides. If it says 17, yeah, just download the most recent version. The most recent version was 16.1 when I did this last, but apparently it's 17.
So is he writing the compiler on
He's not writing the compiler, but he's packaging it all up and making it available for Windows.
He does work for Microsoft though, and he does work on the standard library in Visual Studio.
But, so just if you're waiting for things to download or install, I'll tell you about this. So, unlike most other programming languages, in fact, most other programming languages have like one kind of canonical implementation. Right? So, yes, there are theoretically multiple versions of Java, but almost everybody uses the Oracle JVM. Yes, there are other versions of C#, but almost everybody uses like the Windows.NET implementation. Same with Python. All of these have one kind of really major implementation that's kind of the one that's standard that people use. C++ is a bit different in that there are 3 important major implementations, 3 main compilers that people use that are all used really heavily every day by thousands of programmers around the world. And they are Visual Studio, another one called GCC, and a third one called CLion. There are a few others like Intel and stuff, but they're not used anything like as heavily as the three major ones. Visual Studio is Windows only. CLion works on Windows, Mac, and Linux, and the same with GCC. So we could have everybody everybody on Windows use Visual Studio, but we don't for various reasons. Instead, we get you to download this thing called MinGW, which is, oddly for historical reasons, that's what GCC is called on Windows. So this is this is GCC. If you're running a Mac, then we get you to install CLion, because that's what Apple used by default. Yes?
I found the 30-day free trial of CLion yesterday. I'm not going to need that anymore if I've got this.
You will. So that's step 2. So you're one step ahead. We'll talk about that once everyone's done with this step. I want to make sure everyone's kind of going along at the same time. Yeah.
There's also free stuff for
I'm sorry, say.
CLion, or how do you
CLion, so they're all free. Yes, you can
How
download
do you
them
spell
free. CLANG.
Are there any major differences?
There are, unless you're at the absolute cutting edge, wanting like stuff that has only been standardized a few days ago, there are not really any huge differences between them now. It used to be that Visual Studio kind of lagged behind, and GCC and CLion were kind of a bit further ahead, had fewer errors and were more adherent to the standards. But these days, they're all pretty much the same. The reason we don't recommend Visual Studio is just because we like everybody to use this CLion, and Visual Studio doesn't play all that well with CLion yet. That's pretty much the only reason. On the other hand, if you already have Visual Studio installed and you're comfortable using that, then go ahead and use it. It will do everything that we need to do for this class. Yeah, so if you've already got all this installed, so you don't have to worry.
Just in case if it expires the license.
No, so the compiler is free. You don't have to worry about the license expiring for that.
Not this one for CLion.
But for CLion, and also because you come to these things regularly, and I will talk about this in a second, but we can give you an extended license if you want.
Okay.
So you don't have to worry about that. So you're already Linux, right?
Yeah, but I've already installed.
You already got it. GCC or G++? Okay, so if you, so just open the terminal window.
There's both actually.
Okay, so just type G++ and see what it says. No, that's
there.
fine. Yeah, you're all good. Oh, you're going ahead and doing CLion already.
Yeah.
Have you done this step? Okay. Is there anybody who hasn't done this step?
Are you still stuck? No. Or are you just waiting for it to download?
Yeah, it's even on a fast computer, it takes a long time.
It downloads. Okay.
So have you downloaded one of these? Yeah, and then it'll take a while to. I'm just going to grab some water while that's happening.
Was it from GW? It takes ages to compile.
To decompress.
No.
Link.
Yeah. It does, doesn't it?
Yeah, well, yeah, it's a bit of an issue catch.
There's no workaround, isn't it? Like try using gold or something.
No, there's something, you can do something like F symbol visibility and make most symbols invisible by default.
Oh, F visibility was it?
That's the one, yeah.
Okay. For those.
But then you have to like explicitly annotate things that you want exported in your DLL.
I mean, if you're making a library, yeah.
Yeah.
But for an executable, like.
All right. Well, you seem to already have CLion there, so I'm going on step 2. All right. Everybody else happy with this step? Can I move on? Anybody not happy for me to move on? Oh, it's still extracting. Yeah, the Windows, it takes a while to decompress, even if you've got a fast computer.
I'm finding it hard to install it onto the desktop. I don't know, I think it went into my downloads the first time round, and this is the number 3.
This is now old, yeah. Well, you can, I mean, it's all self-contained, so if you've got it here, you can just drag it to a new location. So it's expanded to your desktop, so you could just...
Do what, sorry?
The plug.
Oh, it's there already?
Yeah.
Oh, okay, I've got it.
Which one is it? Oh, that's not plugged in properly. I know yours is.
Yeah.
That
This is
white
what I
one's
need.
not, I don't think.
Yeah, so if you can just go to this piece, and
Because it is one, doesn't it?
then you can just drag this there,
Into there.
to there.
Uses. Yeah, it works. Thanks.
No, that's all done.
I should have been leaving it on the desktop.
No, because if you put it in this location, then CLion can find it easily.
Okay,
And
okay.
find it by itself. Otherwise, you have to tell it where it is. It's a bit more. How you doing?
Getting extracted. When this one. Where are you extracted? How progress is changing. No, you're already finished.
That's already done.
Extracted.
Okay, so again, you might want to drag it out of your downloads folder and just put it in your like C notes.
Just you.
That's the one. Yeah, and just drag it. Great. All right, so you've now all got a compiler installed. You can, in theory, now write programs in C++. But in order to do that, you'd have to like manually use the compiler on the command line, and it's all a bit awkward. So it's really great to install an IDE. The one we recommend that we like people to use is something called CLion. It's a pun, you see. And this is a commercial product for a company called JetBrains. And if you use it professionally, you have to pay for it. You know, it's pretty good stuff. Fortunately, they offer a free, I think it's 30-day trial or 1-month trial for everybody to just try it out. And then, so today, you don't have to register or anything. You just click a start 30-day trial. Then if you continue coming along to these sessions, JetBrains very kindly give us some licenses for our students to use. So you can contact us and we'll be able to give you a license code that'll extend it for another 3 months. And then if you're still here after 3 months, or after 4 months in total, then we can give you another code and so on. So I've walked around and quite a few of you have done this already, but if you haven't, just go to jetbrains.com/CLion and there's a link there. You can download it for your operating system. It's got an installer on Windows or on Mac. You just drag it into your applications folder. And then the first time you run it, it'll go through the process of trying to detect your compiler. If you've been through the steps on the last one, then it should find it automatically. And so you can just click next a few times. But again, if you've got any questions, just raise your hands and we'll come around. Otherwise, I'll give you a few minutes to do that.
Yes.
I put CLion on yesterday, so
Okay, excellent, yeah.
I'm going to have to somehow
Given that
get it to
the
detect
already
the
understands.
So, yeah, so
What are you
close
asking?
it.
Okay, so what a compiler does is
And
it
take a
takes
figure.
your source code, which is like
For it, and
a text file,
min GW.
Oh yeah.
translates it into machine code.
And
So the computer understands machine code, but it doesn't necessarily, you can't run.
no, it's all good. So you
Oh,
What?
I'm thinking that
And
loads and loads of all sorts of things.
Okay, done.
Yeah.
Interpreting, like,
yeah, perfect.
when I write a Word document, it understands a Word document. And
It understands a Word document because you've got Microsoft Word installed.
Yeah, but so why can't I edit in like just a text document and then send it to what the computer, how the computer understands its programs, which presumably are written in code somewhere. I
So
don't know what I'm quite
the programs on your computer, large
Hard
parts of
coded.
Windows, are compiled programs. Right? They are machine code. Right? So yes, I mean in theory, they could give you a compiler along with your operating system, but you know, 99.9% of people would have no use for it.
It's fine. I think it's fine on the
I
screen.
think it's like it's like because
Yeah.
it's effectively VGA. It's doing like overscan and stuff.
Oh, is it VGA?
Yeah,
Oh, I messed with it.
yeah, I noticed that.
Oh, broke, don't fix it.
Exactly. Oh, the other thing I should mention that if you are a full-time student at a registered institution, then JetBrains very kindly give you a 12-month license, which is obviously preferable to the 3-month license that we can offer. So I can't remember the URL off the top of my head. I think it's jetbrains.com/student. But if you've got student ID you know, for a university or whatever, then I think you don't need a .ac.uk email address to do that. But then you can get a 12-month license, and again continue for as long as you're a student. So recommend you do that if that's appropriate. Yes, what is a debugger? What is a debugger? That's a good question. And what we should do, or what we will do at some point, have one of these sessions where we kind of, as a group, practice using the debugger. But what a debugger is effectively a special way of running your programs where you can pause it at any time, or you can pause it when particular things happen, and your program, the execution of your program will stop and will pause, and then you can examine the memory of your program at that point, right? And you can step through, like, so I said a function is a list of instructions, so you can step through one of these instructions at a time, and then see, okay, what do my variables look like at this point, then run one function, what's changed, run one function, and that way, it's called debugger because it helps you find bugs in your program, right? You can look and you can see, oh, like I've been really stupid. I did -1 when it should have been +1. That's why I'm getting these errors. So that's what the debugger lets you do. And CLion actually has a debugger built into it. And again, it will set this up as part of the tool chain. Is that a reasonable description, Ollie?
Yeah, exactly. I like to use a videotape analogy, with the exception that, unlike a video, well, with a videotape you can rewind, but you can't obviously rewind your program apart from stopping it and starting all over again. And did you mention that you can?
Yeah, so like a DVD, right? You can pause it at any time, and then like it's got that button that takes you one frame at a time on DVD. Debuggers like that. You can go just one step of your program at a time, and you can see exactly what's changed. Because I mentioned
modifying as well. Most debuggers will let you manipulate your values while it's running as well.
Oh.
So if a variable has 5 in it, you can manipulate it to be 10 instead.
all right. Who's still going with this step? Is that a hand?
Yeah, but I don't mind moving on. I think it would be okay because I think
Okay, the only thing is we need to, once that is finally finished, we need to make sure that CLion has the correct tool chain up. Yeah.
Like
press evaluate for free. Whatever, just go to continue at the bottom.
Okay, right.
Okay, so it's just detecting things. Yep, it's found those, that's good. Start using CLion. Okay, you're done?
I just started. We can carry on.
Okay, so if everybody has followed these steps, there's one final thing. That's probably the most important, is to make sure everything is working. So once you've got CLion up and running, in the menus you can go File and New Project. It'll come up with a little window, just make sure it says C++ executable. There are a few other options like C++ library and stuff. Maybe more things depending on what plugins you chose. But make sure C++ executable is selected. The rest of the defaults are fine, so you can click Create in the bottom corner. First time you do this, it might take a few minutes. It's got to like scan all your header files and stuff. There's a little progress bar on the bottom. But once it's done that, you'll see a little icon on the toolbar that looks like a play button. So once it's grayed out until it's finished doing all the scanning, but once that's illuminated, you can click it, and then all being well, it will build and run this C++ project that it created, empty C++ project, and the message "Hello World" will appear at the bottom of your window. So this is the most important step, and this is where things usually go wrong. So if you all give this a try, this is the best opportunity for us to sort out any problems. So give it a try, and if something happens other than what it should, then let us know.
That's finished installing
All right.
now.
Okay, so
How do I?
let's just.
The language standard be C++ 14.
You can just use the latest one. So you should get it to 17. It won't really make a difference to you, but obviously the newest one is that's technically not out, so I'll go to 17 now.
It's working.
Yes.
Should I do this again with 2017 version? Because I left it, it showed 14 and I just let it.
14 is absolutely fine.
Yeah.
For everything we're doing in this module and probably the next few modules.
Alright then.
Just a quick question.
Yeah, sure.
Configure something or just put in settings.
You haven't used it before, right?
No.
Okay, then just go. Okay. Let's just accept the ones. Pick your favourite colouring. And you just do evaluate for free at the top. click the button that says evaluate, edit to enter.
Oh, so you
Okay,
installed CLion 64.
oh, it's detecting it.
That's right, it's thinking again.
Into its own wires. There we go. Yep, it's like CLion.
That's all right. Ollie,
Yes.
how do you edit the path in Windows?
Oh, hit Windows pinballs. Or you can right click my computer, go to properties, which I think is
Project.
there are pause buttons. Yeah, there is, it's that one though, so you do function. What is the function? There we go. So, the advanced settings. Go to environment variables.
Unless it's just an uninstall for CLion, which would be.
Okay, so there's two parts. There's a global one and a user
I
one.
can see the offending line.
There you can see it. Yeah, what's the problem with it though? Because you can just make it add two tool chains. We can just give them add.
No, CLion's complaining.
What's the thing? Really?
It says CLion must not be in your path for the default for GDB to work.
I see.
You may well have to
You
restart.
shouldn't need to restart. Just restart the CLion process. You might want to, well, you should try that now. Hopefully that'll make it not complain. If that doesn't, we can restart Explorer because it might inherit the environment variables from Explorer.
The Strustrop textbook, it's working in 2011. Is it just a case of opening a new project and setting it to 2011 if I need anything?
What's that? What do you
Everything, so newer versions don't take anything away, or at least nothing
Right.
you care about.
Okay.
Right? So everything in the textbook will work if you set 14 or 17 on it.
Unless it's a really bad text.
Oh, okay. At least 11 it says, yeah.
Yeah. And I
Okay.
think the newest edition actually has some updates for 14 just to use some new features. But in general, the newer version of C++ are additive. They
Okay.
do remove some stuff, but they only remove it after like several years of it being not recommended anyway. So, right. We're going to get this working this time. If this doesn't work, you'll have to restart it.
Well, if it doesn't work, we can restart Explorer first. I'm guessing restart this will be
Slagging off his computer.
I'm just guessing. I don't want to hurt your computer's feelings or anything.
It has developed it's like that.
It becomes sentient.
That's why it's slow. It's like,
Yeah.
I don't want to do this.
Yeah.
I want to be on the beach.
A very well developed sense of its own importance.
Great.
All right. Still got the same hour.
Okay. Do you want to keep Explorer?
Well, I'm just going to add. We'll check it.
Did we check that it's also not in the system part? Because it could be in both. That would be really annoying. I'm complaining again.
think eventually this will work. So just when that, eventually when it's finished thinking, that will illuminate in green. Just press it. Okay. Press it. If you have any problems, we're going to do an exercise at some point, and you can ask how it goes. Is anybody else having any problems with this? Or have we all got it working? All right, excellent. You can now spend your time, spend all your free time doing C++, as you should, as any right-thinking normal person does. You spend, yes, every idle hour working hard, writing C++ programs, as we all do. So let's move on and talk about C++. And first of all, talk about something that Ollie, there we are, that Ollie covered 2 weeks ago at the last session. And that was talking about if statements. So as I said earlier, an if statement is a way of making a decision in your program. If something is true, do this, otherwise do that. Right? And again, all programming languages have some version of this. It's one of the basic building blocks of our programs. We test if some condition is true, and if it's true, we execute some instructions. In C++, the keyword to do this, as it is in almost every other language, the keyword to do this is if. Pretty simple. So we need to say if, and then we put some condition that we're testing in brackets. The brackets are important. You'll get an error message if you don't put them in. And then in curly braces, we put the list of instructions that we want to execute. So if this condition is true, we're going to execute these instructions where I've written do something here. And if the condition is false, we're just going to skip all of those and continue executing the instructions that appear after this closing curly brace. We can test multiple conditions. And the way to do this is by saying else if. So if this first condition is true, we execute these instructions in the first block. If this condition is not true, we're going to test this second condition. And if this one's true, we're going to execute these instructions. And if neither of them are true, we're going to do nothing, and we're going to skip down to the instructions that follow the last curly brace. We can have as many of these else-if statements as we like. If this, do something, else if, condition 2, do something, else if, else if, else if. We can chain as many of them together as we like. But one thing that's important to note is that the conditions are tested in the order that they appear, from top to bottom, right? And this can be important, and I'll show you a little example of, in a second, of why it's important. And the last thing that we can do is to have a blanket else statement. So else is what happens if none of the other conditions hold. So we can say, if this condition is true, we do that. If this condition is not true, we're going to test this condition. If that's not true either, we're going to fall into this last block. And obviously this else if in the middle, it's kind of optional. We can just have if something else, right? So this is a way of making decisions, or really a complex chain of decisions almost.
Just a quick question.
Yeah.
The else if, right? What would be wrong if I just kept using if?
So if you said if condition,
And after I just said
So let me. So if you said if condition 1 like stuff, and then down here you said if condition 2 like more stuff, like that.
Yeah.
Yeah? So what this is going to do, is first of all the instructions, it's going to get to this one, and it's going to test whether this condition is true. If this is true, it's going to execute all these instructions, and then move on. If the condition is not true, it's just going to jump to here. And then it's going to execute this. But it's going to execute this whether or not this was true. So if this said else if, then it would only test this if the first condition was false. So with else, this becomes an alternative to that. If you take away the else, then it's always going to test both of them. Does that make sense? Yeah? That clear why that is?
So to make it the same as the else, if you had added something like condition 1 in that second, it would be like condition 2 and not condition 1.
Yeah. But there would be no point because it's much easier to.
Well, if I understood right, first checks the first if condition.
Yep.
If it's okay, executes and jumps to the next one.
So if condition 1 here is false,
Yeah.
we're just going to jump straight to there and start executing this second if statement.
So the same thing happens with else if no.
But if this is true, we're going to execute these instructions and then carry on from here. So the point is, by not using else, we are guaranteeing that this line of code will always run.
If I use else, it
But if-
will go there.
But if we put the word else in here, then what's going to happen is if condition 1 is true, it's going to execute these instructions and then jump down to here.
Oh, so because of the else, we're
Because of the else, yeah. Else means it's like an alternative.
Oh.
Yeah.
Oh, it's okay.
Another way of thinking about this that you might find helpful is to imagine that every if statement has an else attached, and it's just, sometimes it's empty, right? You're allowed to omit it, but omitting it is the same as having an empty list of instructions, right? So if condition 1 is true, we do this, otherwise we do this just happens to be empty, right? And then else if is the same as having your else block and inside it doing if condition 2 stuff. Else empty block. So that's exactly equivalent to just doing if else. Right? This is just kind of being a lot more long-winded about it.
I have one more question.
Yeah.
If we have more else if, obviously it will jump to the last else.
So yeah, if we have lots of else ifs, it'll test the first condition. If that's not true, it'll test the second condition. If that's not true, the third, and so on. And if none of the conditions, none of the else ifs match, we'll do the thing in the final unconditional else block.
Okay.
This is gross. I'm going to get rid. So you might have seen this example last time. We've written a function, it's called greet. And this function takes a piece of input data that's a string, that's some text. In this case, the text represents somebody's name. And what this function does is when it begins, it tests, is the name I've been given equal to Tom? So to test whether two things are equal in C++, we use two equals signs, double equals. So is the name I've been given equal to Tom? If so, we print out hello Tom. If this name is not equal to Tom, so if this condition is false, we run this second test. We say, is the name equal to Ollie? If it is, we print out hello Ollie. If neither of these things are true, if name is not equal to Tom and it's not equal to Ollie, we're going to fall into this third block that prints out I don't know you, which is not actually a very friendly greeting, but there we are. And to use that, so this is our main function, this is where our program starts. So we call the function greet and we pass it the string Tom. So what's going to happen here is that we're going to run our function, and as input data we're going to provide the string Tom. So name is going to be Tom, and then we're going to test, is the name you have given me equal to Tom? Well, in the first case it is, so it's going to print out hello Tom, and then it's going to skip right down here, which happens to be the end of the function. So that's all we do. In this second case, we're going to call the function greet, and we're going to provide it with the input data Stephen. And so we run this function, we say, is Stephen, the string Stephen, equal to the string Tom? No, it's not. So we test again. Is the string Stephen equal to the string Ollie? No, it's not. So we're going to fall to this final else condition, and we're going to print out, I don't know you. Does this make sense to everybody? Yeah? Cool, yeah.
How do you run the bottom bit, greet Tom, greet Stephen? How do you get the final result?
Okay, so when we write C++ programs, we have this. So these two things are functions. This is a function called greet. This is a function called main. Main is very, very special, right? There is main is like a sort of magic function, and what happens is that your program always commences by running the main function, right? So when we compile our program and we run our program, it's going to begin running all the instructions in main, and our program ends when main finishes, right? So the first
am I jumping the gun a bit to see, like, if you use greet Tom, you would get hello Tom coming out, but if you were to use greet Stephen, you would get I don't know you.
That is exactly what happens. Yes, yeah. Yes. That's not jumping the gun. That's what you were supposed to get. So last week, I don't know if Ollie left you with this or whether you went through the solutions. So when I've done this previously, I've left this as a kind of homework exercise. But the idea, there's this very, very, very famous, almost cliched programming exercise called FizzBuzz. And it's basically this. It's that given a number, we do one of four things. If the number that we're given is divisible by 3, we print the word fizz. If the number is divisible by 5, we print buzz. And if it's divisible by both 3 and 5, we print fizzbuzz. And if none of those are true, well, there are various things depending on the particular flavour of the exercise, but I asked you to print not fizzy or buzzy. Right. So this is like an absolute classic like programming test. This is the kind of thing, I think they don't do it anymore because it's such a cliche, but it used to be, this would be the very first kind of thing that employers would do. If you have claimed you're a programmer on your CV, they sit down and write FizzBuzz, and that's like their kind of get rid of all the people who've lied on their CV right from the start. Right? So this is an absolutely classic programming exercise. And then what I asked you to do was to just try it out with a few different values, 99, 125, 225, 1024. So did people do this a couple of weeks ago? Is this, or are you familiar with FizzBuzz? You've seen it in other languages before? Or is this new?
Yeah, we did it last week.
You did it last? Did it last time, okay. So yeah, 99 is divisible by 3, so this should say fizz. 125 is divisible by 5, so this should say buzz. 225 actually is divisible by both 3 and 5, so this should say fizz buzz. 1024 is only divisible by 2, powers of 2, and so this should say not fizzy or buzzy. There are various ways of doing this. Obviously, since I just told you all about if statements, I wanted you to use if statements. So here's my function fizzbuzz. And this is what I was saying about the order of your tests being important when you use if and else if and else if. The order in which you do the tests are very important. So this percentage, that's like, that gives you the remainder after division. So it's, if you remember doing like division in primary school, you said like 7 divided by 3 has remainder 1. Right? This is really, really kind of going back to, as I say, like primary school idea. When you were first taught division, you were taught this idea of remainders. And what this percent thing does is gives you the remainder. So in this case, I% 3 gives you the remainder after dividing the number I by 3. And if the remainder is 0, then that was exactly divisible. So this thing of I% 3 equals 0 says, was the number exactly divisible by 3? So taking the example of 225, so we call fizzbuzz of 225. So our int I is equal to 225. And the first thing we do is test, is this divisible by 15? Because it turns out that if you do a bit of maths, something that's only divisible by 3 and 5 is the same as testing, is it divisible by 15? Right? That's, again, just kind of maths. You could do this another way by saying, by effectively doing both of these conditions with an AND statement. That would be fine as well. But because 3 and 5 are co-primed, you can test it this way as well. But it's important we test this first. If we ordered these things differently, if we did the divisible by 3 test first, what would happen is we put in 225, we say, is 225 divisible by 3? Well, yes, it is, so we're going to print fizz, which would be the wrong answer, because in this case, we want to print, for something that's divisible by 3 and 5, we want to print fizzbuzz. So again, the purpose of this demonstration, the purpose of this little exercise was to demonstrate that the order of these things is important and that they're tested from the first one down. First match. So any questions about fizzbuzz? Well, there are a few new people who didn't get to see this a couple of weeks ago. So,
Is the init int I, is that how you declare the variable?
okay, so int is. So I mentioned at the start how the notion of type is very important. So int is a type. It's short for integer. It means a whole number. Right? So these things, 99, 125, 225, 1024, they're all whole numbers. They're all ints, integers. So this is a function called fizzbuzz, and then we state all of the input data that this function takes. And in this case, this function takes one piece of input data, and the type of that input data is int.
But could you put it in the main and then pass I? No.
So the input data for this function is of type int. We can name it whatever we like. In this case, because I was lacking inspiration, we just called it I. I could have called it input, could have called it flibbertigibbet. It doesn't really matter. We can pick whatever name we like. So I just went with I because it's short. And then we test. So was the number you gave me, was my input data, is that exactly divisible by 15? If it is, we print this. Otherwise, is it exactly divisible by 3? Okay, so we print fizz. Otherwise, is it exactly divisible by 5? We print buzz. And if none of those are true, we print out this last one, not fizzy or buzzy. I think a frown at the back of the room. Is this not happy about this? No, it's all good. That's all right. I would rather people ask questions than just kind of. I usually say this at the start, but a bit of a strange beginning to this session today. But I really like questions. I much prefer this to be a somewhat interactive session rather than just me talking to you. So I always say, like, if you're sitting there kind of scratching your head going, I don't understand this, the chances are like other people in the room are thinking the same thing and they're all too shy to put their hand up as well. So please do. Speaking of which,
this one here with 15, 3 and 5, it's not the same as repeatedly subtracting 3 until you get to 0 or a modulus.
it is the modulo operator.
Oh, so,
Yeah,
so you're repeatedly subtracting 15 until you get to 0.
That's one way of thinking about it.
Yeah.
That would effectively give you the same answer, yes.
And that's how it's done in C++. Like if you're repeatedly subtracting.
No, in real life, it's not done by repeatedly subtracting. It's actually an instruction that's built into your CPU that does this. But in terms of like, in the same way that you can imagine multiplication is done by repeatedly adding something. I mean, in real life, that's not how you multiply, but it's kind of
How it's done, yeah.
a way of thinking about how we could get to the answer. Well, the way you could think about how we might get to the answer is by repeatedly subtracting something. But in the same way that we don't really multiply like this, we don't really work out the answer that way. But if you did that, it would give you the same answer. Yeah.
Does single quotes work as well or not?
No, single quotes and double quotes do different things in C++. So again, this notion of type is really important. So if we use double quotes, that's what we call a string, or a string literal, strictly speaking. So that's like a whole bunch of characters, whereas single quotes are used for one character. So a character is like a letter or a digit or a punctuation symbol. So F is a character, fizzbuzz is a string. So if we just wanted a single character, we put it in single quotes. But a single character has a different type to a string literal. A string literal is made up of lots of characters.
/n. /n is actually, in fact, a single character.
Yeah.
It's a special delimiter for a new line.
Yeah.
And /n is just clean.
/n says, please start a new line here. Yeah.
The way you've done it, double equal sign 0.
Yeah.
That doesn't mean the number 0, does it? If you divide something by 15 and it divides perfectly by 15.
Yeah. So if you have the number 30,
Yeah.
the number 30 divided by 15 is 2, right? But this gives you the remainder after division.
Oh, right. Okay, so there's no remainder.
Yeah, exactly. So if I did 31, that would be 2 with remainder 1. So this percent sign doesn't do division, it gives you the remainder after division.
Okay, I got it.
Yeah.
could you put you could write it with multiple. So in the same if statement, we could write multiple conditions.
Yeah, so I could have, so for this first line, I've just used a bit of maths to say that, well, if something's divisible by 3 and by 5, it must be divisible by 15. But I could equally have written that as if I percent 3 equals 0 and I percent 5 equals 0. And it is actually a keyword in C++. It does what you think. It like chains together multiple tests. It's actually more common to use an exactly equivalent symbol, which is 2 and signs like that. Either will work, they mean exactly the same thing. For some reason, in C++, people tend to prefer doing this, and this is what I do because it's the common thing. But actually, you can just use the word and, which might be clearer. Perhaps I ought to start adopting that for my source code.
That means performance.
No, it's identical in meaning. Right. It's any further questions about this before we move on? Yeah.
Why didn't you use printf instead of?
Why do I not use printf? Good question. So printf is a function that actually comes from C. So C is like a predecessor language to C++. Is like C with stuff added, and C has this function called printf that you just say printf and then like fizz. So you could do that, which is all fine and good in this simple case. So C++ has this very strange way of printing things out, which is with this standard std : cout thing. Character output is what it's short for. And the reason that we prefer cout instead of printf is that we can, as you will see in the next module, we can, when we start writing our own types, we can use cout to print information about our own types, which you can't do as, with printf. Printf only understands the built-in types, whereas cout understands all the built-in types, but it also understands things like C++ strings. And again, as I say, we can also write functions that let us use our own types that we write later to use that with cout. So that's why we prefer this. It's the C++ way of doing it instead of the C way of doing it, basically. All right. Speaking of the C++ way of doing things, let's move on to something new and let's start talking about standard vector.
Just before you jump
Yeah.
across. So I've never used this IDE before. I just want to know if there's a way I can just run like a section of my code. So I've got like loads of things in it. So I just want to run like one particular function.
You have to comment it out.
Yeah, there's not really any sort of built-in way that I know of, but you can sort of achieve that by wrapping it in like comments, so that effectively the compiler ignores it. Maybe I'll come and show you when we have a little break. Okay. So I want to talk to you about Lord and Savior. No, about standard vector. So I've asked this already of the new people, but the rest of you, I'm afraid, I can't remember all the answers, but who's done sort of a reasonable amount of programming before in some other kind of programming languages? A few of you? Yeah, kind of, a bit. If you have, you are probably familiar with the notion of a list or an array, right? A collection of some other data, right? A collection of integers, a collection of strings. And again, this has different names in different languages. Some call this an array, some languages call this a list, some call it an array list, just to be confusing. To be even more confusing, the name for this in C++ is a vector. So if you know about mathematics and you know about vector spaces and all of those things, linear algebra, standard vector is not that, right? I don't know where they got the name from, but vector in C++ terms, what we mean is what other languages call an array or a list. It is a sequence of values, right? And it is one of the most, if not the most useful type provided by the standard library. So that's what the std prefix means, by the way, this std : : that's part of its name. And it means that rather than being built in to the language like an int or a float, it means that this is actually provided for you in this standard library. That's a bunch of code that comes along with your compiler. And it doesn't really make a huge difference in terms of the sort of end user, whether this is built-in type or whether it's provided by the standard library. But it does mean that because it's not built in, we have to use this prefix of std : : This thing is called a namespace, and we'll go on to talk about namespaces in future sessions and how we can define our own namespaces as well. But for now, we just consider these 5 characters as part of the name. Right. So a standard vector is a collection type. It's a collection of values, a sequence of values of some other type. Yeah.
But ordered.
But ordered, yes, and all of the things in the collection have to be of the same type. So for example, we could have a vector of ints, or a vector of strings, or a vector of floats, or a vector of characters, chars. We can have collections of different types, but all of the things within that collection must be the same type. That's why I spent a few minutes talking about this at the beginning. This notion of type is all important in C++, and a bit more so than it is in some other languages, like JavaScript in particular. So vector is actually an example, actually the primary example, of what we call a generic type. It's something that's written in a certain way in that it can adapt to whatever type you try and put in it. And again, if you've done like Java or whatever, you might be familiar with this notion of generics and generic types. Because it's not built in, because it's provided by the standard library, we have to inform the compiler that we want to use this in our programs. And the way we do that is with this special instruction #include and then vector in angle brackets. Just do this at the top of your source file anytime you want to use this type std vector, which is going to be most of the time. You just need to put #include vector at the top of your program. And again, this is like an import statement in Python or whatever. It's C++'s way of including some other code that we didn't write, or perhaps we did sometimes, but in this case we didn't. So vector is very special. It's a generic type. We need to state what type the vector will hold. And we do this using angle brackets. So now we've got angle brackets, square brackets, curly brackets, all the different kinds of brackets. Bracket soup. But in this case, we use these angle brackets, a less than and a greater than sign. Greater than and less than. So for example, standard vector angle brackets int says that we have a sequence, a collection of ints. If I said standard vector angle brackets float, that would be a collection of floats. If I said standard vector angle brackets bool, that's a collection of bools, kind of. Right, and the point is that C++'s type safety rules extend to this generic type as well. So I can't mix a vector of ints and a vector of bools. They're not the same thing, they're different types. This is a good thing. We can change the size of a standard vector over the course of our program. We can add elements to it, we can remove elements from it. Elements being like an item in the collection, right? So we can, if we imagine this is just a list of, say, ints, we can add new things onto the back of this list. And if we want to, we can remove things from the back of it. And the way we add things to it is by using this command push back. Push a new element onto the back of my vector. Right? Well, the number of elements in our vector can change as our program runs. So it's often useful to ask how many things are in this vector. Doing that is pretty easy. There's this command size. And that will tell you how many items, how many elements this vector contains. So let me show you some code that uses these things. So I'm going to use some standard library facilities. I often omit these from slides just because they take up useful space that would be better filled with whatever I'm trying to show you at the time, but I'm being explicit about it here. We're using these facilities from the C++ standard library. IOStream is input and output, so that's that print thing I was showing you, cout. String is the std string, the string type we've seen a couple of times. And then we also want to use this vector type that I'm showing you now. So, here we are declaring a variable. Remember, when we declare a variable, we say the type name equals something. It's how we declare a variable in C++. In fact, there are a few other ways to do it, but this is the one that we'll use for now. Standard vector of int integers equals something. So type name equals initial value. So here I'm declaring a new variable. The name of this variable is integers. The type that I'm using is a standard vector of ints. So this is a vector, a collection, a sequence of ints.
So if I don't have that stuff on the top, that won't work.
for this particular line, you just need this last one. Actually, what will happen is that when you try and compile it, the compiler will come up and say, you're using standard vector, but you haven't done this include vector thing. Did you mean to? And in fact, in your IDE, it will probably give you a little hint that you can click a button and it will automatically add this to the top of your program if you forget it.
Oh, I see.
Yeah,
So
so-
it's just best practice, just put them all in.
It's not best practice, it needs to be done.
Okay.
Right? In the same way that you know, in Python, you have to do like import at the top of your file to like import the modules that you're using. And the same in Java and C# and most well, pretty much all programming languages again have some way of doing something like this. So yeah, IDEs will help you out if you forget. It will kind of prompt you to do this, but it does have to be done in order to say I want to use vector in my program. Otherwise, the compiler itself doesn't understand what a standard vector is. This tells it what it is, and that's kind of the difference between the fact that this is provided by the library rather than being built in like an int. That and this std prefix. So what this does is it declares a new variable whose name is integers, whose type is a vector of int, and then we initialize this variable with the numbers 1, 2, 3. So after this line, I can use this variable integers, has a size of 3, and the elements that are within it are 1, 2, and 3. So what's going on here? Well, again, now I'm declaring a second variable. This time, the name is strings. The type is a vector of standard string. So just like standard vector, string is one of these types that's part of the standard library, it's not built in. So we have to use the std prefix. So this is a vector, again, we put the type, the element type in the angle bracket. So this is a vector of strings. And then we've initialized this with the strings 1, 2, and 3. So the words 1, 2, and 3 rather than the numbers 1, 2, and 3.
Sorry, I got ahead, but I'm guessing I can watch the rest of it.
Yeah, absolutely, absolutely. So integers is a vector of ints, strings is a vector of strings, vector of standard string. And as we can see here, the variables integers and strings, these two variables have different types. We can't mix these. If we had a function that expected as input data a vector of ints, we couldn't try and call that function with this guy's strings. That would be a type error. That's why this notion of type is very important. Yeah.
The curly brackets
Yeah.
that they're using, is that part of the vector, or is that?
You're asking there a much deeper question than you realise. Yeah. So if I was just creating a plain old int, I might say something like int I equals 4. Right? So this is the name, this is the type, and this is the initial value. All simple. What what I'm saying on this line, oh, sorry, I need to give it a name, don't I? Let's call it V. So now I'm creating a second variable here, which I've named V. The type of this is a vector of int. And I'm initializing it from a list that contains the number 4. Right. This thing on the right, this is called an initializer list. Right. So this is an initializer. This thing in curly braces on the right is called an initializer list. It is a very, believe it or not, this is quite a deep rabbit hole to get into. But what it means is initialize it from this sequence of integers that I've given. So vector, in this case, is going to be initialized with 3 numbers in it. The vector integers is going to be filled with 1, 2, and 3.
Is a list sort of a type? I'm asking because you mentioned list like because in some other like.
Yeah, it's an initializer list. Okay, that's what this thing is called. When it appears on the right, when we're creating a new variable and we put this on the right with the curly braces, that's something. It's a very, very special kind of weird thing called an initializer list. And it's basically a way of supplying a bunch of values rather than one single value.
Okay, so the curly brackets basically define this kind of list of values. The reason I'm asking actually is because that book, it says another way to initialize any kind of variable is using curly brackets instead of putting an equal.
Yes,
sign.
yes,
And
so
it
there are.
that, but it's not that this is a different curly bracket.
That. All right, so I have done my best to make this as simple as possible, but actually this is really, really complicated subject in C++. But you know, this is session 3, and I don't want to scare you guys. But yes, basically that equal sign is technically optional, and you technically can leave it out. But for now, we're not going to worry about that because the rules are a bit weird. We're just going to put it in and go. This thing is what I do when I want to give a bunch of values to when I'm creating a new type. Okay, so this first one, I, is just an int, just one value. The vector holds a collection of ints, so we're going to give it, in this case, a collection of values to get started. And we wrap those in the curly braces to say, this is a list of things. What I'm doing here is I'm initializing V with a list that just contains the number 4. So if you are interested and want to know the full horrific story of this, then what you need to Google for is something called C++ initializer list with a Z. But I warn you, it's not for the faint of heart.
It's also terrible.
It's also terrible, yes.
You have to, because technically you should be including initialize list to use it. Obviously, vector includes it, so you get away with it.
Only if you name the type.
If you do like auto x equals curly braces 1, 2, 3, the error is literally like you must include to initialize list.
Anyway, we don't care about that.
We don't care about that.
All right, so as you mentioned, the second last bullet point. Once we have created a vector, we can add new things to it. And the way we do that is by using this pushback command. So I've got my variable strings, and now I'm saying strings.pushback. So if you're familiar with methods in Java, C#, Python, whatever, you'll recognize that that's what this is. It's a command to my strings variable to say, add this new thing onto the end, please. So before the pushback command, at this point, strings is a collection of 3 items. Then I'll run this pushback command, and once I get down here, strings now has 4 things in it.
So, just what would be the use case of that? So, like, why would I not just type in 4?
In this case, you would, right?
Alright.
In this case, obviously, you would have put, 4 in there. But for many applications, you don't know what you're going to be adding to a vector until your program actually runs, right? You might, the user might give you basically, yes, you need to rely on user input or some input to your program to decide what to do. You know what I mean? Like, let's say you wrote a program, and this might be a good exercise if anybody's looking for things to do over the next 2 weeks. The user can enter words, individual words, and then after they finish doing that, you print out all the words that they entered, but sorted in alphabetical order. Well, a way that you might do that, the best way to do that, is that you would, every time they enter a word, you would add it to a vector using this pushback command. And then once they finished, you could sort your vector, sort all the strings in alphabetical order, and print them all out. So the point is that the pushback command adds new things onto the back of your vector.
Sorry, again, just one last.
Yeah, no,
It
that's
says like integers and strings. You're speaking about an error, right? Let's say if I named it, so it's like destiny vector int, but I just called it, let's say Tristan, for instance. Will that still work?
Of course, you can name your variables anything you like. The only limitation is the first character must be a letter. Can't be a digit. Or it can be an underscore as well. But basically, your names can be anything you like, any collection of letters, lowercase and uppercase, digits, and the underscore character. The only restriction is that the very first character cannot be a digit, basically. After that, there's no limitation, whatever you want to call it, make it as long as you like. Yes, if you wanted to call this vector Tristan, if you wanted to name this vector Tristan, that would be just fine. I'd be honoured. The other thing that is not allowed in C++ is you wouldn't be allowed to name this vector integers as well. That is, these two would have to have different names. Right, that would be an error.
You wouldn't override it.
Sorry?
You wouldn't override it.
It wouldn't overwrite it, no. No. Some other programming languages do work like that, but in C++, no, that would give you an error. Yeah. That's better. So I mentioned pushback. The other really essential command is this size command. So pushback modifies the vector, adds new things to it. There is, I didn't mention it, but perhaps I should, there's a corresponding pop back. Pops something off the end of the vector. Pop back does the opposite of pushback.
So it actually removes that from the end of the vector?
Yes, and the vector is one element smaller than it was before. Yeah.
Regarding this vector declaration, if I wanted a vector of int, let's say, to store 3-dimensional coordinates.
Yes, so that's
How would
this is a I was kind of expecting it, but yes. So we can have a vector of some other type, a vector of ints, a vector of strings, a vector of floats, a vector of whatever. There is almost no restriction on what type you can use. And in particular, yes, it is perfectly valid to have a vector of vectors of ints, let's say.
So is it okay like that?
That is perfectly fine. That works absolutely as well. You know, it does exactly what you might think it would do. In fact, this is one way in which you can implement matrices. If you are into maths. Perhaps that's where the name vector comes from. It's like a two-dimensional thing of vectors. I hadn't thought about that before. Anyway, yes, that's perfectly valid. It's quite a lot of typing, as you can see, but it works perfectly well. So yes, anyway, we can add new elements with pushback. The other thing we can do is to say to a vector, okay, what is your size? How many elements do you contain? And we do that with this dot size command. So we say strings dot size. Well, at this point in our program, strings, the vector contains 4 elements. So this last line is going to print out the number 4. That's how many things are in our vector. Really easy.
So if I turn that into a variable and say int I equals strings of size.
You absolutely can, yes. Yes. Yeah. You could. I'm going to call it S because I've already got up there. Equals. Yeah. This is perfectly valid, perfectly allowed. So what we're doing here is declaring a new variable. Its name is S. It's of type int, and we're initializing it with the result of asking the vector how many elements it has. So this.
You mentioned earlier if you ask you the size, it's counting from 0.
From 0, yes. So an empty vector has 0 elements.
For the standard vector of standard vectors,
Yes.
do all the standard vectors inside have to be the same size?
No. Jagged arrays are. And that's why, like in real life, that's not how people implement matrices, but it's one way you could do it. But then you yourself would have to take care of size. Yeah. Yeah.
When I studied basic at school a long time ago, there was a thing like 2-dimensional array, 3-dimensional array.
Yeah.
Is there any analogical things?
The equivalent of a 2-dimensional array is this thing, a vector of vectors.
But that's like a huge thing to write.
I know.
Any simple ways?
Not at this point.
When you speak matrices,
Yeah.
you never explain what is a matrix in comparison to two-dimensional array? Is this the same thing?
Okay, so I mean we're getting into maths now, but a matrix is like a 2-dimensional array of numbers. So this is a 3x2 matrix, right? The matrices can have different sizes. This is an entire massive branch of maths, people called linear algebra. Yeah, these are incredibly common for doing any sort of physical simulation. People want to use matrices and vectors in the mathematical sense as opposed to this C++ sense. So yes, people want to use, so if you've ever used MATLAB, you're going to be familiar with matrices. This is one way, kind of simple-ish way of doing these 2-dimensional arrays, doing this matrix type thing in C++. There are other ways you can do it, and in fact there are very many libraries out there that will do this stuff for you and have incredibly efficient implementations of this linear algebra stuff in them. So I would, if you want to start using C++ for numerical simulations, if you want to chuck away your MATLAB and Fortran, great. But I would recommend like using one of the specialized libraries to do it rather than trying to implement this stuff on your own. Because yes, you can do it, but it's an awful lot of typing, and somebody's already done that work for you. So if you want to know, I can give you some recommendations.
This array, we can iterate over it, does it?
We can iterate over it, yes, and we were going to talk about that, but we're probably not going to have time. Well, we aren't going to have time today, but yes, we absolutely can iterate over. So I said that time permitting, I was going to talk about loops. One of the ways in which we can loop, that is, do the same thing over and over, is we can perform some action for each element in our vector. In fact, oh no, I am going to show you, don't worry. So a vector is an ordered collection. And each element in our vector has an index. Because it's ordered, it makes sense to talk about the third element, the 12th element, the 99th element. Okay, so let's start again over here. Just run out of space, but I've got this vector of integers that is named vec, and I've initialized it, that's just a bit squeezed, but I've initialized it with the numbers 99, 102, and 43. Right? Well, each element of my vector has a position. This is a vector of 3 elements. So I can say, what is in the first position? Well, the number 99 is in the first position. What is in the second position? The number 102. What's in the third position? Number 43. That position, we call it the index. And C++, again, as do almost all languages, has a way of asking, please can I retrieve the element at this position? And we do that using these square brackets. C++, like these days the majority of languages, but by no means all, C++ starts counting at 0. That is, the number 99 in this example has index 0. This is index 0, this is index 1, this is index 2. So what this thing with the square brackets here is doing is saying, please retrieve for me the element at index 0. So what is the element at index 0? Yes, very confusingly, or perhaps I did this deliberately. It's the string 1, right? We could do it over here as well. here I'm declaring a second variable I, type int, and I'm initializing this with the element of vec that has index 1, the element at position 1. So what's the value of I going to be here? 102, absolutely, yeah. So C++ starts counting from 0. But very confusingly, people still talk about the first element of the vector. The first element is the one at position 0. You get used to it, don't worry. But yes, as you correctly said, given this strings vector that is on the board, the element at position 0 is the string with the characters ONE. We can actually do some magic as well. We can use this syntax, this square bracket syntax, to alter elements of our vector, to give them new values. So if I get rid of this, if I were to say vec square bracket 0 equals 1024, what this is going to do is it's going to change the value of the element at position 0. Okay, so after this line, my vector still contains 3 elements. The elements will be 1024, 102, and 43. You don't get it? Okay. This syntax with the square brackets is a way of accessing individual elements of my vector.
Yeah.
Yeah? And the way we access them is by referring to their position in the vector. Positions, you start counting from 0. So if I had an int I, like if I said like int I equals 0, and then the next line I said I equals 4926, this one is going to declare an int with value 0, initial value 0, and then this is going to override that value so that I is now equal to the integer 4926. Right? So forget about vectors for a second, is this bit. Do you kind of get what's going on here?
It is initialized 4926.
No? Well, so the value of our variables can change over the course of our program. They can vary, right? So we create an integer, and the initial value it has when we first create it is 0.
Later it's overwritten.
And then we have lots of code. You know, you've got 1,000 lines of code, and then at some point, one of the things we say, I want to assign the value 4926 to the variable I. Change the value of my variable. Yeah.
You put an index in there which the vector didn't have. You said vec 500.
I'll mention that in a second. That might well be the next bullet.
Still the vector 0.
Yeah. So what this is saying is assign the value 1024 to element 0 of my vector. Right.
Instead of being 0, it will be 1024.
Yeah. And no. It started off. The initial value was 99.
Yes.
This refers to the position.
Yes.
So position 0.
So 99 will be changed to 1024.
Precisely. Yes. Absolutely. Yeah.
You know, nothing.
Yeah.
Yeah, again, so what's, like, again, the use case, wouldn't I just go and change it?
How, well, this is the way you go and change it, right?
But I'll just type in 44 for my, for the second position.
That's part of the function
And-
that might change.
And again, you know, this is like a kind of simplified example just to kind of show you how it is done. In real life, you might need to change the, like, imagine you're writing like a health app, right? And you, like, the user puts in their every morning they stand on the scales and they're like, am I losing weight, whatever. It's a work, yeah, like health app, healthy eating. And so you've got a variable that records their weight, 75 kilos or whatever, and the next day they're 74.2. So you might go and update what's my current, a variable with their current weight with the new weight. Does that make sense? So this allows your program to kind of respond to user input. So in this case, you're absolutely right, we don't have any input to our program. You absolutely could have just put 44 in there in the first place, right? But the point is that this is how you go and allow your variables to change over the course of your program in response to some external stimulus. Okay, so this is exactly what you just asked me, and this is so super important. It's in bright red. If you use an index that is invalid, that is higher than the number of elements currently in the vector, really bad things will happen. Right? This vector on the board, this vector vec, has 3 elements in it. Index 0, index 1, index 2. So the question at the front was, what happens if I try and access element number 500? Right? What if I did this? And this is so important, I'm getting the red pen. Do not do this. This is, right, because what is going to happen is that actually, because C++ tries really, really hard to be as super highly efficient as it can, it's the reason that, like, when people use C++, when they need really high performance code, right? So for when you're writing like a game engine or bank trading software or anything where performance really, really matters, C++ is the language people go for. And so this function, in order to be really fast, it doesn't do any checks for you. It just trusts that you've got it right. When you use these square brackets, it's going to say, all right, I'm just going to, if I had 500 elements. So this is in fact going to write the value or write the bits of the int 124 to some random location in memory. And if you are very lucky, this will crash your program. If you're lucky, this will crash your program. If you are unlucky, you have overwritten some memory in your program, and your program will merrily continue on its way, unaware that something really bad has happened and that some part of its memory has been corrupted. And this is called an out-of-bounds error, and it's the reason for a whole lot of security problems in software that's written in C and in C++. Right? It's because it doesn't do this checking by default. The reason it doesn't do the checking is because, well, checks take a tiny, tiny bit of time, but if you're doing it millions of times a second, then all those tiny little checks add up. So it doesn't do it by default. Fortunately, and I really should have put an example on the board for this, but I will show it to you now, on the slide I should say. Fortunately, there is a way that we can avoid this. And there's a command called at. So this, do not do it. But we can say vec.at 500. So these two lines, well, if we gave them a valid index, these two lines would do exactly the same thing, except that this second one checks to make sure that the index you've given it is valid. So this one is safe, this one is not safe. And what happens in the second case with at, if you give it an invalid index, like 500 in this case, well, what it's actually going to do is throw an exception, but the practical result of that is that your program is going to terminate with an error message, something along the lines of, you tried to access element 500 of this thing that only has 3 elements. Right? So it's going to make clear exactly what you did wrong. So it's rather unfortunate that the nice, easy, pretty way of doing things is unsafe, and this is a bit more long-winded and a bit more ugly. It would be nice if it was the other way around, right? If the safe was the default, then you could optionally do the unsafe but faster one. But that's not the world we live in. So I would recommend, particularly if you're kind of just starting out, it's kind of easy to accidentally ask for an index that's out of bounds. It's very simple, like, you know, people who've been doing this for 20 years still make this error. Right? It's very easily done. And you can avoid it by always using, whenever you need a certain index of a vector, it's to use this .at. Rather than using the square brackets, use .at.
So when you use pushback,
yeah,
you have to worry about that kind of thing.
No, you don't. This only applies when you are asking for a certain index. Right? So with pushback, you don't have to worry, because that's like, yeah, and the vector knows its own size, and whoever's written the vector code has taken care of all that for you. So my strong recommendation is to use .at rather than this square brackets. And I really ought to have put that on the slide, but didn't. I just put some scary red text on there instead. And yes, as I said, if you're lucky, your program will crash. Otherwise, it might carry on, but with bogus data in an uncertain state, and that's really bad. So last slide for tonight. And that's exactly what you were asking about, iterating over a vector. So once we have a collection of some items, very, very, very often, very frequently, we want to perform some action for each element in the collection. Right, it's a really common thing to need to do. And we can do this using the keyword for. So here I'm creating a vector of integers. I've named it myVec, and I've initialized it with the values 1, 2, and 3. What this second line is doing, it's saying for each element in myVec, I want to perform the following actions in the curly braces. Again, just like if statements, just like in functions, we put the list of instructions in the curly braces. So this is going to go through each element of my vec, and it's going to run these instructions each time, repeat these instructions for each element in the vector. And every time it goes through, every time it does this, it's going to name, for the purposes of this code, it's going to name that variable I. It's going to initialize the variable I. First time it goes through, it's going to initialize it from the element in position 0. Second time it goes through, it's going to initialize it from the element in position 1, and then the one element in position 2. And then it's going to finish because it knows how big the vector is. And what you can think of this doing is just giving you a handy name to be able to refer to the element that it's using for this particular iteration of the code.
And my vec, presumably you don't want to change my vec into that.
Oh yes, that's a very good observation. Yes. You should not change, do anything. You should not use pushback or anything else that can potentially alter the size of my vec inside here. Right. You can adjust the value of variables that are inside it, but you can't change its size. That's a bad thing to do inside a for loop. Yeah, no, that's an excellent observation. Yes. So what's this code actually going to do? Well, my vec has 3 elements in it, so it's going to run this list of instructions, just this one instruction, 3 times. First for the number 1, then for the number 2, then for the number 3. So the first time we run this code, I is going to be equal to 1. So this is going to print out 1, followed by space character. Second time, I is going to have the value 2, so we're going to print out the number 2, followed by a space character. The third time, yes, I is going to have the value 3, we're going to print out the number 3.
So basically, there is an option just to print the whole vector in one go, or you have to iterate each element to actually print it.
You have to do this, yes. But there's no reason that you couldn't put this in a function called print vector.
Okay.
Yeah. There's no built-in way to print it. No.
So can I have a question?
Yep.
If I want to add further my vec, let's say with the parenthesis I, does it print?
So I'm not sure what you mean.
stdcli further on to add my vec with those, how do you call it?
Square brackets.
Square brackets.
Yeah.
I. I in square brackets. Does it print the elements of my vec?
No. Remember, the square brackets work on the index.
Yes.
That is the position.
Yes.
Right? Whereas I here is not the index, it's the actual value inside it. Okay, so we are out of time, so we'll just do this very, very quickly.
So let's say if I want to print out should be for int I equals 0, and how?
Sorry, I'll just whatever. Right, so I've got a vector of strings which I've initialized with the string A, the string B, and the string C.
Yeah.
What I can do is for each standard string S, in strings. Well, I can use those strings in some way. I can do something with it. So this is going to loop over each element in this collection of strings. Every time it goes through, it's going to create a variable named s that is initialized first from that guy, then from that guy, then from that guy. So, yes, you're right, perhaps strings would have been a better example here to use because it would make clear that the I you're getting here is the value, not the index. So this, for int I colon myvec, this is technically the name for this is a range for loop. So a vector is one kind of range. There are other kinds of ranges as well. I said talk more about it shortly. We'll talk about it in the next session. And every time, as I mentioned, every time we run through the loop, the variable I holds the copy of the element that we are looking at. So that's a very quick example of how we can use a range for loop to iterate over every element of a vector. In fact, this works for, there are many different kinds of collections that the standard library provides. Vector is just one of them. In fact, it's the most common. But anything that meets the, I guess the collection protocol, if you like, you can use with one of these range for loops. And as I say, we'll talk about that more in a couple of weeks' time. I'm a few minutes over. I apologise, but we had loads of really good questions, and I really like questions. So yes. I don't mind at all. I hope you don't mind. I do have something that I'm going to leave you with. So this is what I'd like you to have a go at. You can take a photo of this or whatever. I will put the slides up online. And they'll be there as well. And then next week, not next week, 2 weeks' time, I'll go over the solutions to that, and we'll go on to talk a bit more about various other ways in which we can do loops, as well as this range for thing. So thank you all very much for coming along tonight, and for excellent questions as well. I always find it a lot more fun when it's more of a dialogue rather than just me nattering up at the front. So thank you. As always, we'll be off for a refreshment afterwards, and you're all welcome to join us at a local establishment to recover from 2 and a bit hours of intense C++. So everyone's very welcome to join. Other than that, that's it from me, and I hope to see you all again in a couple of weeks. Cheers.